Hello, I'm Johnny Mobility, but today you can call me Johnny Proton, because I'm positive you're going to enjoy the show. This is a show about science, so let's do what science does and start with a question. Do you even lift? Do you take hold of heavy objects in the world around you and fight the very forces of gravity to move them to other places in the world around you? As a member of the Air Force's Air Mobility Command, I do lift. And it's a good thing, because heavy lifting is the topic of today's episode of Mobility Science. From paratroopers and speedboats to elephants and killer whales, my coworkers and I lift tons of weight every single day. In fact, 514 reps every single day. Welcome to our gym. And we do it with the aid of science and some massive machines. We call it airlift. But let's look at how we airlift with a little help from science, technology, engineering, and math. How does a plane the size of 6 houses even get off the ground? You've got to use the force. 4 forces, actually, which are described in the science we call aerodynamics. Aerodynamics is the study of air in motion, particularly what happens when it interacts with a solid object, such as an aircraft's wing. It's a subfield of fluid dynamics, which is the study of fluids, that is, liquids, gases, and plasmas, and how forces affect them. Now, when you think fluids, you probably picture a glass of water or milk or Kool-Aid. What you may not know is that not all fluids are liquids. Fluid is anything that flows, that has no fixed shape, and that yields easily to external pressure. So technically, planes fly through fluids, and that's really the only reason they can fly. When it comes to flying, an aircraft requires an up and forward force, known as lift and thrust, to overcome a down and backward force called weight and drag. Together, we'll call them the 4 forces of flight. Lift is the key aerodynamic force here. It keeps an object in the air that would ordinarily fall to or remain on the ground. It's the force that's the opposite of weight, and it literally fights against gravity. Lift, like all physical forces, is measured by the equation of force equals mass times acceleration. You can count how much force is involved with the international unit called the Newton, which is the amount of force needed to accelerate 1 kilogram at a rate of 1 meter per second squared. In the United States, we measure lift in pound force, one of which equals 4.5 newtons. Every object that flies must have enough newtons of lift force to overcome the gravity force acting upon its mass. We'll see these terms again with the other forces of flight. But how does lift work? Lift is produced when moving air is deflected by a solid object. A plane's wing splits the airflow into 2 directions, up and over the wing and down along the underside. The aircraft's wings are shaped and tilted so that the air moving over the wing moves faster than the air moving underneath it. You can try this at home the next time you're the passenger in a car. With your parents' permission, place your hand out the window palm down and feel the tendency for your hand to rise due to this principle, provided that the top of your hand is rounder than your palm. Congratulations! Your hand has just behaved like an aircraft's wing. As air speeds up, its pressure drops, so the faster moving air over the wing exerts less pressure than the slower moving air underneath the wing. The result is the upward push of lift that overcomes gravity with science. This is known as Bernoulli's principle, first coined by Swiss mathematician Daniel Bernoulli. Now, weight is the opposite of lift. In science and engineering, an object's weight is related to the amount of force acting upon it. In the case of flight, it's the force caused by gravity, pulling down on the aircraft times the massive mass of the aircraft. Weight is also measured in newtons, or pounds. To fly, an aircraft needs something else too. It needs a force to push it in the opposite direction of the fluid resistance called drag. also measured in, you guessed it, newtons. Drag, based on Isaac Newton's third law, is the force that opposes an object's movement through a fluid. In most cases, the harder the object pushes against the fluid, the harder the fluid pushes against the object. Returning to your passenger seat experiment, you can experience the force of drag by placing your hand out the window of a car, palm forward when it's moving. Feel the resistance? That's drag. The amount of drag your hand experiences depends on a few different factors, like the size of your hand, the speed of the car, and the density of the air. If you notice when the car slows down, the drag on your hand decreases. If your hand becomes bigger, the drag increases. Thrust is the opposite force that must overcome drag in order for an object to move forward. It's the aerodynamic force that pushes or pulls an airplane forward through the air. Large aircraft, like the Air Force has, produce thrust with 1 to 4 engines. An aircraft flies when all 4 forces work together. Take one away, and the aircraft stays right on the ground. Oh! And a plane that stays on the ground is like a pencil without lead, or a circle. Pointless. Now that we know the basics of flight physics, let's see how they work together in the real world, where AMC can literally make elephants fly with science. One of AMC's missions is to lift and move cargo, people, and equipment, and other things from one location to another, fast. Sometimes we move things like school buses, tanks, helicopters, and yes, even sometimes elephants. And when you have to move elephants, you're going to need a big airplane. Luckily for us, AMC has just one such aircraft, the C-5M Super Galaxy. The C-5 is one of the largest airplanes in the world and the biggest lifter the Air Force has. It's almost as long as a football field and as tall as a 6-story building. Its cargo compartment is about the size of an 8-lane bowling alley. It's so large it can even carry tanks. That's right. It can carry 2 68-ton Abrams tanks. So elephants are no sweat. In fact, the C-5 can carry not just 1, but 12 2,000-pound elephants.
Oh my!
This happens with the aid of 4 giant GE turbofan engines, each producing 229,000 newtons, or 51,000 pounds of thrust. That's the power of 800 cars. But when you're dealing with a plane this big, how do you know how much you can lift? Well, by using a little math. Let's take a look. Many different factors go into the equation that determines how much we can lift, and our lifting technique. This includes where the cargo is loaded, where it's going, how long the runway is, and whether in-flight refueling will be used. Even Mother Nature herself plays a role. But back to the math. To determine the total cargo load, given the aircraft's lift and thrust ability, an Air Force loadmaster will begin with the max gross takeoff weight of 840,000 pounds for a C-5. This amount includes the weight of the plane's body, plus fuel, plus cargo. Next, the loadmaster will subtract the weight of the plane's body and the amount of fuel needed given conditions. What's left is available poundage for cargo, also known as the allowable cabin load. Finally, a game of Tetris ensues as the loadmaster determines how everything should be stacked, balanced, and strapped down. Under his direction, cargo will be loaded onto the aircraft, and we're ready to go.
Let's go, Sonny!
But there's still one last step to making elephants and other massive things fly. Takeoff. Magnificent sight that I never get tired of seeing. I hope you've enjoyed today's episode. When it comes to learning, the sky's the limit, only if you choose. Stay tuned and you'll start to eat your homework, because I'm telling you, it'll be a piece of cake, as easy as pie. Future episodes of Mobility Science will deal with everything from photons traveling light to whether or not radioactive cats have 18 half-lives. And even sometimes we'll talk chemistry, but only periodically. If you have an idea for a future episode, let us know in the comments below. Otherwise, join us again next time for another amazing adventure on mobility science. Keep lifting, my friend.